Good morning, children. Welcome to Commodore Group of School online classes. Last class we discussed about Newton's third law of motion and its application, and we are able to know today about conservation of momentum. So in last class, what we have learned Newton's third law of motion. So what it explains here: when one object applies force on another object also applies the same force on the first object in opposite direction. That only we used to call it as action is equal to minus reaction. For every action, there is equal and opposite reaction. So its applications, what you have explained here is a fish when it moves in water, through its fins, it pushes the water backwards so that the water pushes the fish in forward direction. Similarly, when we are swimming also, we push the water through our hands backwards. So the water which is in backward, it pushes the body so that it moves in forward direction. So we are able to swim easily there. So rocket also works under the principle of Newton's third law of motion. And you have learned about a balloon also, just can be moved in the form of a rocket. So that activity is called balloon rocket activity here. And another one is action and reaction forces acts on two different objects here. So yesterday we explained about that cork moves in forward direction, test tube moves in backward direction. So action and reaction forces acts on two different objects here. Today we are going to learn about the conservation of momentum. So conservation is nothing but protecting or preservation of the momentum here. So what we are able to observe here is in this activity, here we are taking a U-shaped tube here, and at the bottom here it should be in a horizontal manner. In part B place you are placing 5 marbles, and at part A you are placing 1 marble here. And whenever if you leave the first marble, this 1 marble will go and touch the other marbles, and here this 1 marble which is at the corner, it is getting displaced here. So in part A, 1 marble will come and collide with the remaining marbles, and later on from part B onwards, 1 marble is getting displaced. From that what we can understand here, the mass and the velocity of this marble, that is the product of mass and velocity, is called momentum. So the momentum of 1 marble before collision is equal to momentum of the other marble after collision there. So momentum is getting conserved here. Similarly, here in part B, you have to take 4 marbles, and in part A, you are able to take 2 marbles here. So whenever if you leave these 2 marbles will go and collide with these 4 marbles. Then here you are able to get here 2 marbles, and the remaining this corner 2 marbles are getting displaced here in this manner. So the same thing continues whenever you take 3 marbles. Here at part B, 3 marbles will be displaced. From that what you can understand, the number of marbles before collision, the momentum of number of marbles before collision is equal to the total momentum of the marbles after collision here. So that is said to be the conservation of momentum. So that can be proved by using Newton's third law of motion. So for this you are taking here a marble of mass m1. It is moving with the initially a velocity of u1. Another marble m2, it is moving with the velocity of u2 here. So this is the second marble. And what we are able to consider here is this marble is moving with the velocity u1. It is greater than the marble which is moving second marble moving with velocity u2 here. So what happens? This first marble will come and collide with the second marble for a period of time here t. So whenever they both gets collides here, the first marble applies a force of F1 on the second marble, and second marble a reaction force it applies on the first marble, that is to be F2 here. So after this collision, these marbles are getting separated and they are moving with different velocities. So first marble moves with the velocity v1, second marble moves with the velocity v2 here. So from this we are able to prove the conservation of momentum. So what you are able to see here is first marble momentum you have to find out here. So momentum is the product of mass and velocity. So the momentum of first marble is here m1 u1. So product of mass and velocity. And what is the momentum of second marble? Second marble momentum is here mass is m2 and velocity is u2. So the total momentum of these two marbles before collision is to be taken as m1 u1 plus m2 u2. So this is the total momentum of these two marbles before collision. Now if you observe after the collision, the first marble having mass m1 but the velocity moving here is with v1 here. So the momentum of the first marble here is m1 v1 and momentum of second marble is m2 v2 here. So what is the total momentum of these two marbles after collision? So there is nothing but you have to sum up these two here. So m1 v1 plus m2 v2. So this is the total momentum of the two marbles before collision and this is the total momentum of the two marbles after collision. From this what you can able to observe here is that momentum before collision is equal to momentum after collision. The total momentum before collision is equal to the total momentum after collision. This we are able to prove it here. So that only here, whenever you are taking the two marbles, here you have four marbles. If you leave these two marbles, they will go on to collide with this four marbles, and here onwards two marbles are getting displaced here. So the momentum of these two marbles before collision is equal to the total momentum of the marbles after collision. So this can be proved by using the Newton's third law of motion. So for that we require a tabular column. I will draw the tabular column now. So if you observe in the tabular column, we have marble 1 and marble 2. So momentum of marble 1 before collision. Before collision, if you see, the value is m1 u1. So here momentum of marble 1 before collision is m1 u1, and momentum of marble 2 before collision is m2 u2. So here we will write m2 u2 here. Next, momentum after collision. After collision of first marble here it changes its velocity v1 here. So momentum after collision is m1 v1. So here we will have m1 v1. Similarly, for second marble after collision, the momentum changes as m2 v2. So next, here change in momentum. Change in momentum means from the final momentum to initial momentum. We have to subtract the final momentum and initial momentum here. So initial momentum is subtracted from the final momentum. So you will get here m1 v1 minus m1 u1. This is change in momentum of the marble 1 here. So change in momentum of marble 2 is m2 v2 minus m2 u2. So m2 v2 minus m2 u2. This is change in momentum of marble 1 and marble 2. Next, you have a rate of change in momentum. Rate of change in momentum means that is a ratio of change in momentum with time. So you will get here rate of change in momentum is here m1 v1 minus m1 u1 divided by the time of interaction is t here. So divided with t. Similarly, for marble 2, rate of change in momentum is here m2 v2 minus m2 u2 divided by same time here t. So this is denoted with delta p by delta t. So rate of change in momentum is denoted by delta p by delta t. For the rate of momentum of first marble, we are taking delta p1 by delta t, and for the second marble, delta p2 by delta t. So Newton's second law, what it explains here, the applied force is directly proportional to rate of change in momentum. So these two forces are both are equal. So according to Newton's third law, for every action there is a equal and opposite reaction. So here the marble 1 applies a force of F1 on the marble 2 here, and marble 2 applies a force of F2 on marble 1 but in opposite direction. So action is equal to minus reaction. if you just put the values here, delta P1 by delta T is nothing but equal to here F1, and this value is nothing but equal to F2 here. If you put the values here, you will get here M1 V1 minus M1 U1 divided by T is equal to, here we will have minus, so you have to start parenthesis here, and M2 V2 minus M2 U2 divided by T here. So if you just transfer this T to other side, then you will get here M1 V1 minus M1 U1 is equal to minus of M2 V2 minus M2 U2 divided by T here into T will come. This T is sent to other side here. Then this 2 times time and time gets cancelled. T gets cancels here. You will get here M1 V1 minus M1 U1 is equal to minus M2 V2 minus M2 U2 here. So in next step, you will get here M1 V1 minus M1 U1 is equal to, this minus you have to multiply inside here. So you get the minus M2 V2 minus into minus becomes plus, you will get M2 U2. So if you rearrange the terms here, you are able to get here minus M1 U1, if you send to the other side it becomes plus here. Here minus M2 V2, if you send to left side, left hand side, it becomes plus here. So if you get, after rearranging, you get here M1 V1 plus M2 V2 is equal to, here minus M1 U1, if you send the other side, the right side, it becomes plus. So you get M1 U1 here plus M2 U2. So this can be rearranged like this here. You are able to write M1 U1 plus M2 U2. This part is equal to, here we write M1 V1 plus M2 V2 here. So this is the total momentum before collision is equal to total momentum after collision. That only you are able to prove it here. So basing on Newton's third law, action is equal to minus reaction. You are able to get, you are able to prove it, the conservation of momentum. So from that what you can understand, when net external force is absent, the total system is said to be isolated. That the total momentum remains unchanged. So that is about the law of conservation of momentum. Next concept is impulse. Impulse is denoted with the letter J. It is also called a change in momentum. So what is impulse means? Impulse is nothing but the product of net force and interactive time here. So this change in momentum, that is also called as change in momentum. Change in momentum is a product of net force and time here. So how we are able to get this formula here is from Newton's second law, force is directly proportional to rate of change in momentum. F is equal to delta P by delta T. If you cross multiply these two, you will get delta P is equal to F net into delta T. So change in momentum, that is called impulse, is a product of net force and time, interactive time here. So if you observe here, this time as well as this force, both are inversely proportional. If you have a longer period of time, the force acting will be very less here. If you have a greater time here, the force acting will be less. If you have less time, the force acting will be more here. So basing on this, you have an activity here. So you are placing, you are taking two eggs. One is placed under the floor, near to a floor, and if you leave the egg falls on the cement floor and it breaks here. Another egg you are just leaving on a pillow here. If you just at the same height, if you leave another egg, it falls on the pillow. But this egg do not break here. What is the reason here is, in the first egg, whenever you are leaving here, this will fall with a force here. That force come to stop with a short period of time. So that more impulsive force, here short period of time, and time is less, more force will be acting. So that more impulsive force will act on the egg and the egg breaks here. But here what happens, whenever the egg is placed above this cushion below, and if you leave it, it falls on the cushion, and due to its elastic nature, this total force, it is extended with the time. The time of contact is getting extended. So the force is acting for a longer period of time here, so that to contact the pillow, it takes a longer time, and less impulsive force will act on the egg. So the egg is not breaking here. So this is the usefulness of that impulse here. So basing on this, in our day-to-day life also, you have this impulse is used here. So if you observe a pole vaulter, this pole vaulter, he will carry a long pole and he will jump to a longer height here. On the other side, it is provided with a cushion foam bed is provided here. So whenever he jumps on this other side, he falls on this cushion bed, and the total force will be just acting for a longer period of time here. So the time of contact is extended. Due to the cushion effect, the time of contact is getting extended. Whenever there is a longer period of time here, the force will be less. So that less impulsive force will act and you won't get any pain here. If you don't have this pillow, then his bones will be fractured here. So you are able to provide here with a sand or else a cushion or foam bed is provided. Similarly, in a cricket, when a person fielder in a cricket game, when the fielder is catching a ball, he has to just catch the ball and he has to drag his hands to backward direction here. Why means whenever he catches a ball like this, the total force will come and act to a short period of time from here to his hands here. The total force will act to the short period of time. So more pain will come to the fielder and he will miss the ball here. So he will leave the catch here. To avoid that one, whenever the ball is coming, he will take the ball, he will catch the ball and the ball is getting dragged so that the time of contact to the hand is extended. Whenever it is getting extended, then less force is acting to the hand and you will get less pain there. So that is how impulse is used in day-to-day life. Similarly, airbags are provided in the car here. So whenever the car meets an accident, that time airbags are getting opened so that the driver will go on to touch the steering. Within the time, airbags will prevent him to touch the steering there. So that like damages can be avoided. Children, here we have an example problem. A water tank having a mass of 12,000 kgs. Inside will have a shell. The shell mass is of 300 kgs. Initially, these two are under a rest condition. So, your initial velocity of the water tank is u1 is 0. That shell velocity, initial velocity is u2 is 0 here. Whenever this water tank fires the shell moves with a velocity v2 of 400 meter per second. Whenever it fires the shell, this water tank will move backwards with certain velocity v1 there. So that is called a recoil. After the shot, the velocity of the water tank you have to find out here. So this is applied by the conservation of momentum. So we have the momentum before collision is equal to momentum after collision. So m1v1 plus m2u2 is equal to m1v1 plus m2v2. Basing on this formula, we are able to find out the velocity of the water tank after the shell is shot out here. So, if you put the values here, you know m1 value is 12,000 kg. So, you put m1 as it is, u1 value is 0, and m2 write down as it is. u2 initially the velocity of them is at rest position. So, u2 is 0 there. Here, we have m1 v1 plus m2 v2. Now, m1 into 0 becomes 0 plus m2 into 0 becomes 0. Total left hand side becomes 0. You will get m1 v1 plus m2 v2. So, from this, you have to find out here v1. So, just if you send this m2 v2 to the other side, you will have m1 v1 is equal to minus m2 v2. You have to find out the velocity of this water tank here. So v1 is equal to minus m2 v2 divided by m1. If you put the values here, m2 value is here 300 kg. So that is the mass of the shell, and the velocity is 400. divided by m1. M1 is the mass of the water tank, that is 12,000 kgs here. So this 2 zeros gets cancelled. Here 1 0 gets cancelled. 3 ones, 3 fours. Here 4 ones, 4 10 times you get here. And here you are having minus sign. So you get to minus 10 meter per second. Velocity unit is meter per second here. So the velocity of the water tank is 10 meter per second. Why you are getting minus here means that is it is moving in the opposite direction. So you are able to get minus here. So velocity of the water tank after the red shot is fired is 10 meter per second. Here ends our chapter 2, laws of motion. Up to now what we have learned in all the classes, first Newton's laws of motion. So Newton has given 3 laws, Newton's first law of motion, second law of motion and third law of motion. So what Newton's first law of motion explained, every object remains in the state of rest or uniform motion unless an external force acts on the object here. In that Newton's first law of motion is also called the law of inertia. What is inertia? Inertia is nothing but not accepting the change. It is a tendency of all the objects to be in the state of rest or motion unless external force acts on the object. And the next topic what I have learned here is about momentum. Momentum is nothing but a product of mass and velocity. So why you are able to get momentum means that is for the Newton's second law. Using a momentum concept, you are able to give second law of motion, Newton's second law of motion. In Newton's second law of motion, what it explains, what it states here, so that Newton's force, total net force is directly proportional to rate of change in momentum. That is Newton's second law of motion. So later on we have a concept as Newton's third law of motion, that one object applies force on another object also applies force on the first object with the same magnitude but opposite in direction. That is Newton's third law of motion. For every action there is equal and opposite reaction. Later on you learned about conservation of momentum. When two objects are getting collided, the total momentum before collision is equal to total momentum after collision. And last concept what you have learned is impulse here. Impulse is a product of force and time. So these are all the concepts what we have learned in second chapter, laws of motion. Thank you.